So good morning, everyone, again, and welcome to the first session of the three-part virtual series focusing on drinking water issues within Pennsylvania and West Virginia. Like I said, before we jump into the presentations, we're going to briefly just review some general housekeeping for today's session. Firstly, as you all have seen, you have just received a prompt that a recording has occurred, and you will be required to provide your consent to stay in the meeting. This recording will be made available to all of the participants, and it will also be made available online through the West Virginia Water Research Institute webpage. If you haven't already done so, please take a minute to introduce yourself within the chat. And also during the presentation, please make sure to mute yourself and remain muted. We will have time for a question and answer session after the presentation, so please be sure to type any questions you may have within the chat box or hold on to your question until the end, in which we will welcome you to come off mute and engage with our presenters and all of the other attendees. Our presenters for the day are Melissa O'Neill, Associate Director of the West Virginia Water Research Institute, Stephanie Karchevsky, Undergraduate Student Researcher, Lance Lynn, Professor of Civil and Environmental Engineering, and Rachel Pell, Water Resources Specialist. So without any further ado, please welcome our first presenter of the day, Melissa O'Neill. Melissa, take it away.
Well, good morning, everybody, and thank you for joining us today. I certainly appreciate everyone's time, and we only have an hour, so we're going to try to move things pretty quickly here. So I'll go ahead and get started. The West Virginia Water Research Institute was established under the Federal Clean Water Act. The U.S. Geological Survey supports a water research center in each state and territory. Since 1967, the West Virginia Water Research Institute at WVU has been developing solutions to important environmental economic development issues and disseminating the results to the public, legislators, and government officials. Although West Virginia Water Research Institute is housed at WVU, we're not confined by the geographic border of the state. We work diligently across state lines to address water quality issues at watershed-based scales. You can advance to the next slide, Kristen. You can go ahead and jump to the 3RQ one. The Three Rivers Quest is a program of WRI, and it's funded by the Colcom Foundation. 3RQ monitors rivers, tributaries, and headwater streams that drain an area of over 25,000 square miles in 5 states. It brings together academic researchers, citizen scientists, and conservation groups to collect, analyze, and monitor important water quality data. The Waters database serves to house collected data, and 3RQ Esri maps make that data available to the public. In addition to our routine monitoring, 3RQ has been involved with completing targeted studies throughout the Upper Ohio River Basin. Citizen concerns over total trihalomethane reports from drinking water facilities launched our studies into THM, focused in Southwest Pennsylvania. Since then, we've received funding from USGS to continue looking at THM issues with our current work in West Virginia. So thank you guys for joining us today. And with that, I'm going to hand it off to Stephanie.
Hi, everyone. I'm just going to give a little background information. So disinfection byproducts form as a result of the reaction between the natural organic matter that is present in effluent and in disinfectants such as chlorine or ozone. The formation of disinfection byproducts is usually a greater concern for water systems that use surface water, so such as rivers, lakes, and streams as their source. It is important that we balance the risk posed by pathogens against the chronic risk posed by lifetime exposure to potentially carcinogenic byproducts. And the two most prominent classes of disinfection byproducts are trihalomethanes and haloacetic acids. You can go to the next slide. So we know that the current limit for total trihalomethanes is 0.08 milligrams per liter. Achieving this can be difficult, and violations occur all across the US very often. Rural low-income water systems typically experience the greatest number of violations, and repeat violations are also extremely common in violation hotspots. It can be noted that in general, the brominated DVPs are more genotoxic and carcinogenic than the chlorinated compounds. Recently, in response to THM violations, programs have been created to help. So one example is the area-wide optimization program. And through this program, states can voluntarily work together to develop and implement programs to support public water systems with the optimization of their treatment processes and distribution systems. Next, we have haloacetic acids. So these are organic compounds containing chlorine and or bromine. Levels in the water can vary from day to day depending on things such as the amount of acid in the water, the season, water temperature, concentration of chlorine, and the amount of plant material in the water. The established maximum applies to the combined amount of all five. So at this time, we would like for everyone to answer this poll question. In your experience, are THMs or HAA5s a bigger issue? If you can't see the poll, you can type in the chat if you'd like. We'll just give you guys another 30 seconds or so to do that. All right. Does everyone have a chance to answer the question? Okay, we'll end the poll, and I think Rachel will be discussing the results later. So next up, we have methods for minimizing the disinfection byproducts. So many plants are already implementing these methods. The first we have is chlorine alternatives. Using chloramines instead of chlorine during secondary disinfection has been shown to generally form less THMs and HAAs than when just using chlorine alone. A drawback of using chloramine is that it has been linked to corrosion and lead release issues. Another great alternative is UV disinfection. That requires little operation and attention and would not alter the taste or odor of the water. Drawbacks for that include the need for pre-treatment of water and a very high dose of UV to kill certain viruses. Under oxidation, we have ozone treatment. So this treatment has been used around the world for many years. Ozone itself is a powerful oxidizing agent, which when dissolved in water, produces a broad spectrum biocide that destroys all bacteria, viruses, and cysts. The greatest THM and haloacetic acid reduction is seen when ozone is combined with a chloramine. But unfortunately, advanced oxidation process technologies are generally not economically feasible. Others include coagulation, flocculation, sedimentation, membrane filtration, activated carbon absorption, and photodegradation of the natural organic matter. And a couple of those will also be talked about later. Last, we have methods for removing the DBPs. So there is biological degradation of haloacetic acids, which is both rapid and efficient. Next, we have air stripping, which removes contaminants by contacting clean air with the contaminated water, causing the contaminants to move into the air. Air strippers can efficiently and effectively remove THMs below regulatory limits, and that's important because it leaves room for the generation of more THMs during the water's path through the pipes until the point where it's used. Lastly, we have activated carbon, and that's effective and works best for low molecular weight and uncharged organics. I think that's all I have, so I'm going to pass it over to Dr. Lin.
Okay. Thank you, Stephanie. Again, my name is Lance Lin. I'm going to talk about a master thesis that was done by a graduate student a few years back to look at the THM formation and the controlling factors from the data we collect in this southwestern Pennsylvania. So, kind of see what we can find, what we can learn from the real data, and then the practice at the water authority that we collaborate with, and hopefully, learn a few lessons. And here's the results. I'm going to use about 10 minutes to go through the slides, and then if I'm moving too fast through the slides, we'll have time at the end of the meeting, to revisit some of these slides if necessary. So next. Okay, so the objective is if we can take the source water monitoring, the data, and then somehow have some predictive model for the THM formation in the distribution system, and that's one thing we looked at. Another thing is we wanted to learn if there's any practical lessons that can help minimize the THM formation. So we took a look at the historical data from the Charleroi, one of the water authorities that we work with, and then we're going to talk about that a little bit. So next. Okay, the study region, again, is the southwestern Pennsylvania, and there are 3 water districts: Charleroi, Tri-County Joint Mission, and then the southwestern Pennsylvania. And we actually collect water sample at the intake of the treatment plant, and then when collect sample from the distribution system of the finished water as well. So and Melissa's group and then the students, they actually analyzed all these water quality parameters we thought relevant to a THM formation, including some of the anions, because with all the shale gas development in the region, there was a concern of potential contamination of those produced water. So we looked at the bromine or bromine in the source water, and to see if there's any potential impacts at all on the THM formation. TOC, total organic carbon, and a typical one, total dissolved solid, electrical conductivity, pH, and all that, and then of course the THM, including the total and the individual. Next. So analyzing the data, try to find a correlation between the source water quality and the THM formation. So we looked through, we went through several steps of analysis, trying to find a relationship between TOC, THM, and see if there's any seasonal variation. The bromine being incorporated into the THM to see, what the potential impacts of that. And then regression model and sensitivity analysis to see what is the parameter, water quality parameter that affects the THM formation the most. Next. Okay, so again, Charleroi data, and then we look at and see what we can learn from it. So next. Okay, here's the data. Okay, the source water, and you see the data was presented in different seasons. So you see the fall, and you have warm temperature, and then one thing we found interesting here is the bromide concentration is low throughout. So at that kind of low concentration, are we going to see any bromide being incorporated in the THM, or is going to substitute the chlorine in the THM at all? And we're going to show some results. Chloride, is fairly low, 6, 8, and 8, and TOC, there's a slightly elevated TOC concentration in the fall. And then that's a bad combination with the elevated temperature. So that's what we found, that's a detrimental in terms of the THM formation. Next. Okay, so this is a correlation. Again, that temperature and TOC combination, the positive correlation, and I think that's becoming a dominant factor for the THM. Next. So Nasheed started with this, trying to explore to see if there's any relationship between the TOC, which is on the X here, and the TTHM in the distribution system. The data include all 3 water authority. See, this is a general positive trend there, positive correlation there. But if you break down, divide the data just for the individual water authority, you see each water treatment facility kind of give you a different response. So that means the treatment practice matters, and also the distribution, system. And so you get this a different slope between the TOC and TTHM. All right, next. So this figure shows the seasonal variation. Okay, I'll explain it a little bit. For each of the month, for example, the September here, and the X here is the TOC concentration from 1 to 3. So if you see data point that kind of concentrated to the right of for that month, that means you have elevated TOC situation. And then on the Y, this is the temperature again. If your data cluster to the upper right corner, that means you have a high TOC concentration with warm temperature. So you see this dramatic, variation in the temperature, and then, TOC concentration vary according to that as well. Next. So here's the THM data. Again, we presented for different months. September, you see all these. If we have that 80 microgram per liter, drinking water standard, draw a line here. You see all the water authority, data shows that by exceedance of that standard for TTHM. And September is probably the worst according to the data. And then October, you see there's a couple of them in the exceedance. And then as the temperature started to cool down, in November, December, you see, THM concentration drop significantly. Well, the X, okay, the THM concentration range vary. And then when you get into the late spring or early summer, in the May, you start to see violation again. And the figure to the right, you see the orange bars here, these are the chloroform. That means 3 chlorine and 1 hydrogen attached to in the methane compound is the predominant THM. But interestingly, you see the blue bars here. That's bromo dichromomethane. That means you have 1 bromine in that methane compound. And throughout, you see about 10% of. Okay, no, you see there's around 10 microgram per liter. Okay, it represents 7% of the total THM. Even with that low bromide concentration in the source water, you consistently see certain amount of brominated, THM. I thought that's very interesting. Next. So okay, so here we took a closer look at the bromine incorporation or substitution factor (BSF) there. Just ignore the data that are below detection limit to the left here. You see for a bromide concentration from 0.02 to about 0.05. You see, there's no clear correlation or trend there. That simply means if you detect bromide in your source water, you're gonna have certain amount of the total THMs in the brominated form. So the figure to the right, pretty much share the same message. If you have a higher total THM concentration, that additional THM are mostly chloroform. Okay, so next. So this predictive model, a simple linear regression shows here's the measure, the actual THM concentration and the predicted by this model here, linear regression model here. TTHM is a function of chloride and temperature and the TOC. So you see this positive sign of the coefficient in front of temperature and the TOC that simply suggests the positive correlation. But both contribute to the formation of THM. Next. So we did sensitivity analysis. The bottom line here is the temperature is the most sensitive parameter, controlling factor for THM. Okay, so elevated temperature will affect the THM formation more than any other factors, water quality parameters. Next. So we took a look again, Charleroi, how they operate their treatment plan, the water intake from Mount River, and then that water is stored at the wet wells there, and then treated with the permanganate going through this mixer, inline mixer, and then there's a pre-sedimentation tank. Okay, just allow any particular matter to settle. And that goes through this, there's a 250 micron screen to remove any particles, if there's any, and then go through this flocculation tank, just a slow mixing. And that water is chlorinated here, okay? And then go through this membrane filter. This is a micro filtration unit to remove any residual, particles or any, organic matters. And that water is stored there at the clear well before, adding this chemical agent to prevent corrosion, and then goes to the distribution well. So next. And okay, so we are next. Okay, so, and this is the, okay, well, I'll present the data first. Okay, so they put in this sedimentation tank, that pre-sedimentation tank around 2015. And this data is just to compare the effects of that pre-sedimentation tank on the THM. So we broke down the data into 2 periods. And the figure to the left, that's the data before that, they have the sedimentation tank, and the figure to the right is the after. So you see this blue dots, or this curve there is a TOC concentration. And you can see the TOC concentration hover, between 40 to 80 milligram per liter. And that's a very consistent before the sedimentation tank was put in, and then after, except this data point here, okay, the elevated. But even with that consistent TOC level, the THM concentration was quite different before and after. Okay, so you see there's a fairly, frequent exceedance of the THM standard 80 microgram per liter before the sedimentation tank was put in. And after that, they have the sedimentation tank. Even with the similar level of TOC, the violation or the magnitude or the concentration of THM was much lower. So that shows the effects of the sedimentation tanks in mitigating the THM formation. Next. Okay, this is just show the chlorination, the dose, okay, and they have there. Again, I think, this is the chlorine concentration, okay, post-chlorination, that's the chlorination of the finished water. There, this is the real chlorine concentration. And the red, the cross, the data point there, that's a THM data. Okay, again, I think this elevated THM in the Q3 there, that's because the temperature effect. Okay, and then you see still somehow elevated THM here in October there. I think that's mostly because of the temperature. All right, next. So a few conclusion and discussion point. Hopefully, that simple linear model, it seems to identify important factors, and temperature is most significant one. Okay, and so what we need to watch out, it seems most of the exceedance of the THMs happen in the fall season. And what we learned from Charleroi is that the sedimentation tank help in mitigating, maybe smoothing some of the particular organic matters from the water. And the slide I showed previously, maybe there's an opportunity to try a different chlorination location. Maybe they can do the chlorination after that membrane filter. Maybe I wonder what, maybe that will further mitigate the THM formation. Now, alternative secondary disinfectant, Stephanie talked about that a little bit earlier. So, and that's the one thing that they maybe will consider. Okay, with that, I conclude my presentation here.
Thanks, Lance. Hi, everyone. I'm Rachel Pell, and I'm a water resource specialist at the Water Research Institute. and I'm going to talk a little bit about the current study that this team has going on. So in this study continuation, we wanted to build on the previous study by evaluating different methods for THM formation. So our original focus was THMs, but we quickly realized that we needed to consider the haloacetic acids as well. So our approach was to meet with different facilities to learn what is being used locally, what works, and what doesn't. And after we started having these meetings, we realized that we were in a position to facilitate conversations between different stakeholders. And so that's really what we're doing here with this virtual meeting series. It's really for you all to be able to discuss and share, and for us to continue to learn. So for next steps for this study, we're hoping to build some consensus during these virtual sessions on developing a clearer picture of disinfection byproduct issues in this area and best methods for treatment. And we're hoping to produce a white paper which includes recommendations for future studies. We also wanted to expand from the previous study geographically into West Virginia, as well as a bit further north into Pennsylvania as well. So we started reaching out to facilities basically to see who would be interested in participating in conversations surrounding disinfection byproducts. And we ended up with some really great collaborations. And so I just want to take a second to thank everyone who gave us some of their time to work on this project. So thank you. And as you can see from not only from these flow rates, but also from the maps, you can see that these facilities that we worked with have a lot of variety amongst themselves. So we have several larger facilities with varying numbers of direct and indirect consecutives. We also have the Preston County PSD #1, which is a smaller and more rural facility. And while they're all located in the Monongahela River Basin and they all utilize surface water, their water sources are all different as well. So the Municipal Authority of Westmoreland County, or MAWC, we focused on their McKeesport plant, which gets its water from the Youghiogheny River. The Morgantown Utility Board, or MUB, their water is drawn from the Monongahela River. The City of Fairmont from the Tigert Valley River, and Preston County from a reservoir on Deckers Creek. And so we spoke with these facilities, and we also found a lot of variety in their treatment processes, of course. So these are some of the methods that we found were utilized to reduce disinfection byproducts. And they include steps both at the treatment and also in distribution. Treatment methods can include reduction of precursors as well as chlorine alternatives. And they included covering clarifiers, ultrafiltration membranes, chlorine dioxide, and Paracetamic Acid. And I'll go into a little bit more detail about those methods in a second. Distribution methods included routine flushing. This varied from anywhere on a monthly basis to more like a couple of days, really whatever was necessary to meet the optimization goals for turnover in the tanks. Another method was power vents and mixers in the distribution tanks. Okay, so ultrafiltration membranes are selectively permeable membranes which remove suspended matter and pathogens above their rated size. Now, there are two different modes of operation for these membranes. First being dead end flow, where the feed water flows perpendicular to the membrane surface. The other option would be cross flow, where the feed water flows parallel to the membrane surface. Now, there's benefits and drawbacks of both. In dead end flow, low energy is needed, mainly because there's no need for recirculation, as no unwanted particles can make it through. The drawback is that there is buildup on the membrane, which can restrict flow over time or flux, and it also produces reject water, which needs to be discharged Afterwards, it can potentially be recycled though. In crossflow, we have force. The force of water keeps the membrane surface cleaner, so we have a more reliable flux. But the drawback is that there is recirculation needed, and so more power needed for that as well. City of Fairmont is a great example of the utilization of ultrafiltration membranes. Their membrane was installed in 2003, and at that time it was the largest east of the Mississippi. I'm not sure if that's still the case, but they utilize an immersed membrane operating under low negative pressure or a vacuum, and they have an open tank design as well. And so in this system, flow is automated according to the water level in the clear wells. And so I believe that after their initial installation, they did have to make a few adjustments to their overall system to really optimize the use of these ultrafiltration membranes. And since then, they have had excellent results. They've seen really great reductions in disinfection byproducts, and I don't believe they've had any exceedances. Another method that we saw is chlorine dioxide as a alternative to chlorine. And this is a gas at room temperature, an oxidant. And so it produces lower levels of disinfection byproducts compared to chlorine gas. It does have a few drawbacks, one being that additional salts such as sodium thiosulfate may need to be added to the water. But overall, we saw that the Morgantown Utility Board had excellent results using chlorine dioxide and no exceedances as well. Really quickly, I'm going to talk about Paracetamic Acid as well. This is a pre-oxidant and it has no known toxic byproducts. And while it is NSF 60 approved and a food quality compound, it has yet to be used in Pennsylvania. And so this is really an emerging alternative method. And the Municipal Authority of Westmoreland County has completed several promising preliminary studies on its use. And so it's a very exciting opportunity. And I don't want to speak too much about Mock's study. I don't want to steal anybody's thunder, but I know that they've been involved in many presentations and are very interested in sharing their results. So I don't know if Laura's on the call today, but there's a lot of potential for some discussion questions on this topic. Okay, so we have another poll question. Which alternative method do you find to be the most promising? And if you really don't know what you believe, you can also say other. Okay, it says 11 have answered. I know we have a couple more people on the call, so I'll give another second. Feel free to also put it in the chat. And we'll be talking about this a little more later when we have things open up for discussion. So, oh, there's another one. So it looks like the highest is chlorine alternatives, a lot for ultrafiltration or ultra membrane filtration, and also a lot for other, which we can talk about more, which I'm interested in. So I'm going to end the poll. Okay, and so as we looked at these facilities, we also looked at the occurrence of their brominated THM forms and just overall trends. As you can see, chloroform is the dominant species, followed by chlorodibromomethane. We had fairly small percentages of the brominated THM forms. As you know, brominated forms are more carcinogenic. They can also be representative of differences in source water bromide levels and could be indicative of disinfection byproduct removal techniques as well. Same thing for the haloacetic acids. We see quite a dominance of the dichloroacetic acid and the trichloroacetic acid as well, and very low levels of brominated forms. So here are conclusions. These are in addition to the ones presented by Lance from the initial study. We found that generally disinfection byproduct issues are more common in small rural systems as well as consecutive systems. This is no surprise. It's a trend found across the country. We also found that the haloacetic acid reduction methods need further study. And I was interested in the poll results. More people indicated that trihalomethanes were more of a concern. But one of our trends when speaking to facilities was the greater concern for haloacetic acids. So that's interesting. And I think we need to talk about that a little more to build a better consensus. And finally, we also found that a multifaceted approach works best. Some additional issues that are related to disinfection byproducts that we found when speaking to these facilities were things like analytical lab delays, a lack of reliable technical assistance, the issue with an alert going out to everyone in the distribution system, even if it's not affecting that area, and also some additional issues with the quarterly averages. And so these are some things that we want to open up for broader discussion, not only at the end of this session, but really during the next 2 sessions. We're hoping to do some roundtable discussions. And so these are things to start thinking about and start thinking about how these issues are related to the chemical issues. So some acknowledgements, USGS and the Colcom Foundation have funded these research efforts. And here are our contacts. We'll be sharing this recording afterwards and also our contact information. If you're interested in learning a little bit more about how we got started with these studies, this is a link to our story map, which has some really nice information. All right, so at this time, we'll open it up to Q&A for anyone from the team. I know that Kristen's going to facilitate, so I'll turn it over to her.
Yeah, so at this time, there are no questions within the chat, but please feel free to come off of mute and ask any questions or talk about anything that you want to maybe discuss further. The floor is yours. So if anybody would like to come off mute or just type it in the chat, either or, we will be able to answer any questions, concerns, issues you might have. And then Melissa did end up putting a link into the chat for future drinking water seminar discussions. So please feel free to visit that as well. We did have 2 comments during the presentation, just talking about previous experiences with the Fairmont plant, as well as temperature variations, especially within the 3rd quarter. So they shared the sentiments. Thank you, Charles. It was an excellent presentation. It was extremely informative.
While we're waiting for questions, we can also open it up to discussion and keep thinking of questions. If they come up, feel free to put them in the chat or just unmute yourself. But I'm wondering if anyone would feel comfortable with sharing, whether you voted for THM or haloacetic acid, just kind of elaborating on that more so we can begin to really understand which is a bigger issue. Are they both equally as large of an issue? Are they both so intrinsically tied together that you can't choose one or the other? Does anyone want to talk more about that?
I mean, I guess I would put some input with it. This is Aaron with PSD1. Typically, from what I've seen, is your haloacetic acids is typically more towards your aged water issues. And as long as you're keeping a flushing routine, your trihalomethanes is typically a treatment process. You're having issues with your TOCs, which they both correlate, but you tend to run into more of a trihalomethane issue out in the distributions than you do haloacetic as long as you're flushing.
Excellent point. Does anybody want to add to that, or does anybody have any questions regarding that information? All right. Rachel, you came off of mute. Did you want to respond?
I don't want to put Mike Horanek on the spot, but if he is available to speak to whether or not he's seeing that on a regional scale, and kind of his interesting perspective. Mike?
Yeah, this is Mike. As far as Fairmont, and I was hoping Bethany would be here with the Pennsylvania Drinking Water Program, because they're starting to see byproduct issues with their membrane plants and scratching their head saying, no, why is this happening? In the distribution system, we're starting to see mixing going in there, and forced demand devices like timers to force. Preston County PSD4 has one more to keep a chlorine residual in there. So fresh versus stale is always better. And I was a little surprised because THM formation is not much of a priority now, but 2 weeks ago on a Friday, a couple of the Fairmont systems called up, said, geez, what's going on? THMs and HA5s in the 150 to 100 range, and for the purchasers. So what do we do? Well, the rest of the data is in, and it's just those 4 purchasers. Everybody else is elevated in the third quarter, which is not unusual, but getting 2 quarters backed up is not a good place to be. Oh, Bethany and I had talked about when you do have issues, it's great to have either master meter or plant effluent byproduct levels. I know in Fairmont one time they were putting out some higher HA5 value. So that tells you if you focus on the distribution system or the plant side, because trying to tackle it all at once can be an issue. But getting fast, reliable results back, the only thing we've seen is maybe Hurricane using THM Plus. It's a Hawk product.
Thank you for that added explanation, Mike. We did have 2 other questions come into the chat. Trevor Waters asked, any helpful tips on how to lower TTHM and HAA5 within a satellite system other than flushing?
This is Steve Bowers with Cape and Springs and Farms. I used to work for the town of Romney, and we had really high TTHMs, and we ended up flushing pretty regularly, but we went also with cleaning our pre-sedimentation basin. Instead of once a year, we did it every 3 months, quarterly, and that really brought our levels down. We didn't have any issues after that.
Great. Thank you, Stephen. I appreciate that. Does anybody else have any feedback or want to add to this discussion at all? We did have a reply in the chat from Chris, just saying that they agree with the speaker in regards to being able to better control the HA5s by implementing a regular flushing routine. Has anybody had similar experiences or would like to share maybe a different experience that they may have? All right, well, we do have some more time for any open discussion, any questions that may have not been addressed yet, may be a little bit unrelated, but still related to the drinking water issues within the particular region that you're representing. So please feel free to come off mute or just type it in the chat and I'll be happy to read it aloud to the attendees and see if we might be able to get a better discussion going. We did have one question from Charles Adams asking, what is a satellite system? Did any one of the presenters want to particularly handle this question?
This is Mike in Bureau for Public Health. Satellite is just a consecutive system. So, you know, Fairmont has 17 satellite systems. Fairmont didn't have any issues. Their satellite systems in 2018, looking at some of Lance's data, 2018, that's a good year. They had 33 or 35 HA5 violations and 1 THM violation. And we scratched our head on that. But I think that's from 2 consecutive quarters just being extremely high. Cleaning the said basin, I just typed in well, is an excellent point because that's to have helped. At least in that issue. And I think there's some natural variation going on too, that for whatever reason, I'd say temperature plays a large part to it, is good. Now with all these inline monitors too, I think taking a look at these organic UV 254 data is timely.
On that, Mike, this is Lance. It seems that a fast monitoring results back, having that fast monitoring results back, and then respond accordingly is an important issue because we have heard about this several times now. Any ideas, or this is a question for everybody. Any idea that we can have maybe new tools that we can have to either monitor the surrogate or real TOC or even THM, that we can, any tools or any methods that we can have a fast turnaround time to get the results and then, hopefully respond to that.
This is Mike with Bordertown Utility Board. QC analyzer is very important. The type that we have is a GE product, and we look at raw. We use it also for source water monitoring for any spills or whatever it may be. But we also can do analysis on our finished water and see what kind of removal we're getting with our treatment process. And it all starts back at your source water anyway, no matter how you look at it.
Mm-hmm.
For example, MUB has 62 miles of different streams and rivers and things like that we deal with. So it's challenging. We have 3 dams that we have to deal with. We have 20 some different pressure zones in our distribution system, which amounts to 20 some different little systems out there. So every one of them have their own little way they work. So that is very challenging. The third quarter just works. Third quarter is always, I heard Mike say something about having THM of 100. A lot of times you're happy if you have that because you could have had 200 because you're working yourself to death. And there's not really a good I mean, you can look at the science part and get some idea, but there's not really a good science way to attack the halos, especially. There's just not a commonality you can come up with other than water age.
Thank you, Mike. And thank you, other Mike, for addressing the question about a satellite system. Does anyone else want to add to this discussion before we address one more question in the chat? All right, well, we do have one other question in the chat from Trevor Waters asking, we are considering a tank mixing system in a water project. Has anyone had any positive results for a particular system that they would like to recommend? Has anybody had experience with something that they would not recommend? Do any of the presenters want to add anything that might help in their decision-making process?
This is Steve Bowers. I just want to say, I know Romney implemented that a couple years ago when they installed a new tank, put in a mixing system in it. I don't know how it's worked, but you might want to call them and talk to them to see if they would know.
This is Aaron with PSD1. We 3 years ago installed a solar beam mixing system in all of our tanks, and we saw a dramatic drop in trihalomethanes throughout our distribution.
Thank you both for adding to that discussion. So it sounds like we have a couple of options, either reaching out to another area or being able to utilize the, I'm sorry, Charles, can you repeat that one more time? I don't want to mess it up. I know that you said solar beam mixing, but I want to make sure that I'm getting it right. No, it looks like they might be frozen now. Of course, right at the right time. Oh, they're unfrozen. Charles, do you want to say that one more time? All right. Perfect. Well, it doesn't look like we have any other questions coming into the chat. Rachel, did you want to finish with anything in particular, any discussions, anything to think about before the next virtual session that we have coming up in 2 weeks?
I can just add that, you know, some information about the next 2 sessions. So they're going to be a little bit different. This session was focused on kind of framing the issue and explaining our role in the study. The next 2 sessions are going to have outside presentations. So next session we'll have Emily Garner, who is also a professor of engineering here at WVU. And she has a study going on that's we found was pretty interesting and closely related to our study, where she's looking at levels of bacteria throughout the distribution system and how that affects water quality. So she's going to give a short presentation during the next session, which is November 2nd. And then we're going to follow that up with some more roundtable focused discussions focused on disinfection byproducts in general. And the third session, which is November 16th, we're going to have a presentation from Mitch McAdoo from USGS, and he's going to share some of the results of their PFAS study, which is going to be really exciting. And during that session, we'll have a discussion more focused on other emerging issues. So we're going to move away from disinfection byproducts a bit and open up some more broader discussion on emerging issues like PFAS, really anything that, you know, we want to build a consensus on what are the issues in the area and what are going to be the issues in the next few years. Oh, I was just looking at the chat. That was just Kristen asking. PSD1 to repeat.
Yeah, Charles. Yeah, it sounded like Charles was lagging a little bit, so I was just asking for him to type it into the chat so that everyone would have access to it.
Gotcha.
Perfect. Well, thank you for the preview of the next 2 sessions. And again, this is a recording that will be distributed to all of the participants for you to review at your leisure, and will also be available on the West Virginia Water Research Institute website. So please feel free to visit the link that Rachel provided in regards to the story map of these studies, as well as exploring other programs that the Water Institute has to offer. And if there are no other questions or discussions that anybody would like to get into.
Christina, I just want to add one quick comment. I
Sure.
hope the forum that for not just one way, communication, presenting new studies. I hope this is an opportunity for everybody to get together and just share the experience. What we learned, we have been given training workshops in the past. But one thing we learned is, simply having everybody together and then just share the experience. And then a lot of time you get your problem resolved in a very simple way. So I hope this is an opportunity that for you guys, that's helpful for you guys, just come, spend an hour, and then there's the opportunity for you to share your insights, your expertise, your knowledge, and then hopefully help others as well.
Perfect. Thank you, Lance. We always would love to see the connection building between communities. And of course, as you've heard here, we have a lot of the same issues. And of course, there are different regions that have been able to have successes that could be passed along to other regions. So we love to be able to accommodate the community and grow it a little bit more. So thank you all for joining us today. And we look forward to seeing you all on November 2nd for our second virtual session of this 3-part series.
Yeah,
thank you all
for joining us.
Thank you all so much. And I hope you have a great rest of your Tuesday, and we will all see you soon.
Thanks, everyone. Bye.